Let's have a look at some examples of writing noble gas shorthands for some elements and for their ions. So here are elements: calcium and calcium ion, and iodine and iodide ion. So what I'd like for you to do here is hit pause, and go ahead and write the noble gas shorthand notations for the calcium atom and calcium ion, and then for the iodine atom and the iodine ion. All right, so push pause now, go ahead and write those things out, and when we come back, we'll look over what you got. Okay, so for calcium atom, we are going to go back to the previous noble gas, which is, what are we looking at for calcium? Argon. So argon, previous noble gas core, and then 4s2. So for the ion, these 2 electrons will be the ones that we get rid of. So for calcium ion, it's just the argon core. Again, the ion is the previous noble gas. For iodine, now things are a little more complicated because iodine is way down there toward the bottom. It's krypton, core, 5s2, 4d10, and 5p5. But notice 4d10 is not in the valence level. It's 4 instead of 5. So we have these 2, 5, 7 electrons in the outermost energy level. So the iodine ion is going to go here to 5p5, which is going to make this 5p6. And instead of krypton, now we're talking about xenon. So the iodine ion has the same electron configuration as the xenon noble gas. All right, now here's why we care about this stuff. So if we want to write the formula for a compound, all right, so using the information on the electron configurations that we just wrote, describe what happens when calcium and iodine react. What is the formula for the compound of calcium and iodine that results from that? So again, I want you to push pause here, and then when we come back, we will have a look at what the actual electron, or not the electron configuration, but the formulas are going to be for that. Okay, so the information on the electron configuration describes what happens. Well, if we go back here, calcium has 2 electrons it wants to get rid of. Iodine wants to gain 1 electron. So we want the argon and the xenon noble gas configurations. But here's the kicker here. This is 2 electrons to get rid of, but iodine can only get 1. So if we want to get rid of 2, it's not going to want to just get rid of 1. That's not going to help, and that's not going to give it its octet. It's got to get rid of 2. So what it can do then is give 1 to 1 iodine, and then give the second one to a second iodine. So the formula for a compound of calcium and iodine, which we could have used just the system that we had before, well, we know that calcium is 2 plus and iodine is 1 minus. So if we just do the crisscross thing, we would have gotten Ca1I2, so Cai2. But now we can see why that's the case, because calcium has 2 electrons to give up, and iodine takes 2 electrons. So these 2 electrons go over here to 2 iodines, and that's why it's calcium iodide, Cai2. All right. Now, one last thing. This system that we're talking about works most of the time. The problem is at the top of the periodic table. The previous noble gas in some cases is helium, which has only 2 electrons. So the octet rule applies for most things, but in some cases there's actually a sub-rule called the duet rule, but we don't really need to worry that much about it unless we're talking about things like lithium, beryllium, which are relatively rare.